Welcome to Lesson 2, Example 2 for beams and columns, and it is asking us to find a beam of negligible weight supports the loads shown above. Solve for reactions R1 and R2. So we're supposed to solve for R1, R2. I'd also like to do, once again, do the shear and moment diagrams if we have time. So let's go ahead and get on it. First thing you do is you solve for R1 or R2. The easiest thing to do, remember you have your three equations of equilibrium. Sum of the moments in the y direction equals 0. Sum of the forces in the y direction equals 0. Sum of the forces in the x direction equals 0. And then sum of the moments about a point equals 0. And as we said before, there aren't any forces in the x direction, so that's not going to help us. There are two forces in the right direction, so we're not going to be able to isolate one of these, so we want to use the moment, and we'll be able to isolate either R1 or R2. For instance, let's go ahead and call this A, and then B, and if you sum the moments about B, R2 is concurrent with B, and therefore will not induce a moment, and the only thing that induces a moment is R1. You'll be able to solve for that. So let's go ahead and do that. Let's solve for, let's say, sum of the moments. What did they do on the example? He actually does both, but I don't want to see what he actually did. So I'm just going to say the sum of moments. Let's say positive. Sum of the moments about point A equals 0. Let's go ahead and get started. We'll go from left to right. A, R1 times 0 is 0, so we don't even need to put that. And therefore we're going to isolate R2 and solve for R2. 1500, that's going to do a moment that way, which is a positive moment, so I'm just going to do 1500 pounds. The pin's working better, I'm a happy camper, times 4 foot. And then we're going to go ahead and do equivalent load here, and that's 800 pounds per linear foot. That's what PLF stands for. 800 PLF times 8 foot is, let's see my calculator out, is what, 6,400 I believe, but let me do it on the calculator so I don't have to. It is 6,400. 800 times 8 is 6,400. So we have an equivalent point load of 6,400 pounds. I don't know if I said 6,800, but it's 6,400 pounds. And then that's also a positive moment. It's going to create a positive moment rather. 6,400 pounds times, well, we know it's 4 foot here, another 4 foot, and then it's half, another 4 foot, so 12 foot to that point load. So what is that? We said 12 foot. And then we have our R2, which is going to induce a negative moment. So we're going to do minus R2 times 20 foot. And then we solve for R2. I'm just going to go ahead and do it in my head. So 1500 times 4 plus 6400 times 12 is going to give you 82,800, which you're going to switch R2 over the opposite side. It's going to become positive, and you're going to divide 82,800 divided by 20 is R2 equals 4140. And you should be able to follow that. If you can't, just work around the algebra at first until you get used to this. So you'll multiply these two together, you multiply these two together, you add them, you will throw this on the opposite side, you add positive R2, 20 to each side, and you divide by 20. And I pray that you understand that. If not, that's alright. Go to the Khan Academy and look at something else. We'll get used to it over time. So let's see if we got R2 right. And they are 4140. That's what we got, 4140. So we're good. We're going to continue on. The next easiest way to go, since we only have one force in the y direction, unknown left, that is, we can go ahead and use the sum of the forces in the y direction equals 0. And you have R1 going up, is what we assumed. It could be, theoretically, it could be going down, but we know it's going to be going up. but that's what we assumed. We assumed up. If this ended up being negative, then our assumption was incorrect, and it's actually going to be down. But our assumption is going to be right. So we have R1, we have negative 1,500 pounds. We have a negative 6,400 pounds. And then we have a positive R2, which we know is 4,140 pounds. Let's go ahead and add up what we have here. We have a negative 1,500. We have a negative 6,400. We have a positive 4,140. That's going to give us negative 3,760, and you add 3,760 to both sides. You know, 1 equals 3,760 pounds. Once again, algebra. If you need to write out steps, let's go ahead and do that and check it, and it's 3,760. So we're good. Those are your two reactions. 1 and 2. Now, to do the shear and moment diagrams, that answers the question that they asked. But we're going to go a step further and do the shear and moment diagrams. I'm going to quickly erase because that was done in 6 minutes. So hopefully we can do this in less than 9. Wish me luck. Erasing. Shoot, I erased the reactions, so I'll use what they have. Alright, let's erase. And erase. And although I erased the reactions, I actually have the answers here in the example test, or study guide, whatever you wish to call it. R2 was 4,140 pounds. Apologize for my nasty writing. And 3,760 pounds. All right, and now we also, if you remember me saying this in the last video, you also need to change this equivalent load and get rid of it. You want to have the distributed load. So any equivalent load that you made from distributed loads, you need to change back and say, okay, we just have 800 PLF again. So erase it all. And this is important when you're going back to the shear and moment diagrams, because that will confuse you. I remember there were a few times back in school where I would have it as that and I'd get confused, which I am wiser now. Don't do such things. All right, shear. So this means the shear. I'm going to give myself a little bit more space this time. This is the shear about distance x. So it always tells you to shear the whole distance x. And we're going to go start up. We're going to go up 3,760. We start here at 0. We're always going to start. I know in the last video I said do you? I was kind of confused about that and wasn't 100% sure, but you do. You will always start and end at 0 for shear and moment diagrams. So my assumption was correct. 3,760 pounds. This is always going to be pounds. I'm just going to put it down here. And then, well, there's nothing right here, so you go straight over. So right here, you're going to have 3,760 again at 4 foot. At 4 foot, you're going to be 3,760. Then you go down 1,500 pounds. So 3,760 minus 1,500 equals 22. That's going to be about right here, 2260. 2260. Now you go straight over because there's no distributed load or anything, so you'll go straight over to the distributed load. Another important point, as I will call it, I'll look and see if they have a more technical name for that. And this is also going to be 2260. I'm not going to write that again. But at this point, you are decreasing at a uniform rate. You're going down at a uniform rate. So your slope is going to be uniform down. But you want to figure out how much at the end, how much did I go down? What point is this? 16. At 16 foot, how much did I go down from 8 foot? So that's 800. It's the area under this curve, which is not a curve. It's this area right here. One moment. And the area under this rectangle is 800 times 8 foot. 6,400. So you take 2260 and you're subtracting 6,400, and that's going to be where this ends right here. So we can track it down, and it's going to be about right here. And it's negative 4140. So let's scale it to approximate. If that's 2,000, it's going to be about double that. So about 4140 is right there, give or take. And you come down here. And this is negative 4140, and that's pounds. Excuse me. And then you go, there's nothing here, so you're going to go straight over. And then 4140 up, and you're into 0. And that point is 4140 as well. So I hope this makes sense. And actually what you want to do, you can see, I'm not going to call them point of inflection, but your 0 intercepts, where it intercepts this line right here, you want to figure out what those are, because that's going to end up being your maximum positive moment right here. So let's go ahead and figure out where that is right now. So we're at 2,260, and we're going in negative 800x, because that's your slope, remember. Negative 800 is your slope, x. And then we want that to equal 0. So at what point from this, that's x right there, are we going to equal 0? So let's figure that out. And bring 800x to this side, so it's 2260 divided by 800. It's going to be, x is going to equal 2.825 foot from this point right here. So it's actually, what, 4 plus 4 is 8, plus 2 is 10, 10.825 feet from, and that's from point A. All right, so that's our intercept point, and that'll help us here in a second. Let's hurry up and do this. And that's going to be in foot pounds. All right. So we want to break it up into areas here. We'll do this one first. We'll call this area 1. And then let's break this up. This will be area 2. And this is probably the better way to go about it. This will be area 3, this smaller triangle. Area 4 is that triangle. And then area 5. Area 5. Alright, let's go through this quick. And I might have to pause it when I'm doing calculations. But we are increasing the same, but this is a square, so it's kind of, and it's positive. So you want to think of it as kind of confusing, but it's positive, so you want to go up, and it's the area, it's uniform, I would call it. So it's going to be the same as when you're looking over here. So you're going to go positive to what? Up to what? Let's not make it that drastic. And it's the area under this curve, which is 3760 times 4 equals 1540. And then you want to add A2, which is 2260 times 4 plus, and 2260 times 4 is 9040, and 9040 plus 1540 equals 2480, so 24080. And once again, it's a linear line, but now we're in it, since this is decreasing at a linear, this is going to be linear to the second power, so it will be a parabola. And that equation is going to be 0.5, since it's a triangle, times 2260 times, what did we say, 2.825. And that equals 3192.25. And let's erase this real quick. And since that is going to be a parabola, it's increasing less, so it will eventually go to 0. And that, I mean, the slope's going to go to 0. The slope's going to go to 0. And that's 2480 plus 3192 is 27272.25. And now we come down, we're decreasing, and it's going to be at another parabolic. It starts at 0 and it goes to the max, and that will be 0.5 times 0.5 to this triangle times 5.1 175 times 4, 4140.